And so this is, I mean, this is going to be unstructured at best. But our goal is to have a high level discussion about network architectures and compare notes, learn from each other,
Okay.
what we need to learn. And I mean, like I said, unstructured, so I don't have an agenda of any sort. But I thought maybe a good place to start was to talk about networks and architectures independently and then put them together and apply them to telecom.
That sounds great.
You mentioned earlier about like making things as complex as possible. Like that's what this is going to be. I'm afraid.
It was like do I know of many architectures? I mean, I guess there's like individual network architectures, but like I don't think of architectures much outside of telecom.
Well, right. So I mean, maybe let's start there. Like, cat set art or set network, set telecom aside. Like architecture, what does it mean to you?
To me,
Yeah, I say.
Well, okay. So the word architecture, like broadly speaking, what
Yep.
it means to me. Not how something is constructed, but like the like physical makeup of something, right? Like the components that go into something that is a whole.
What do you think, Kelly? What does architecture evoke?
So for me, it's sort of how something is built, but it also has to do with its purpose because different types of things are architected differently. And it also sort of has to do with, and I have a hard time sort of leaving the telecom thing behind, but thinking about it mostly in how things are connected. Like, and that sort of applies to buildings as well. Like it's, how do you connect one room with the next? Is it a doorway? Is it a hallway? Is it,
Yeah, I mean,
where do you put your walls? Where's the barrier between the inside and the outside?
I think this is all right. Like there's connectedness, there's physicality, and there's like an arrangement. But I think like that physical part of it is really interesting for me because if you ask me like architecture, Sean, what is architecture? Like I wouldn't have a clean definition. I'd have an example. And so I'd give you like the example of like a global financial architecture. Like, well, what the hell does that mean? Well, it's like, okay, the IMF, the World Bank, the Fed, the Bundesbank, private banks, individuals. It's all this big system that's connected, and each thing has a role, and the role of each thing affects the other things that are in the architecture. And it's not static. It always changes. Like after World War II, Bretton Woods, we repeg, inflation and monetary policies, and the global financial architecture changes.
Well, but that's an interesting point because to me, each of the things in there is its own architecture. And to the extent to which it is a large system is more incidental than intentional.
I think that's an excellent point, and I think that's like the segue into the network piece of it too, right? It's like the things are unto themselves, but the connection between them is like the thing itself would be different if it wasn't connected to the other thing. So that network effect, right? And so I mean, then that's like, okay, well, what is a network?
Telecom network?
Any network. I mean, any network.
I was like, can we please get back to telecom?
sorry. This is my impulse all the time.
So I mean, yeah, but
I mean, if you're going to any network, I think that is really about connections. I mean, before the World Wide Web, you just had a bunch of computers and they couldn't talk to each other. If you wanted to run the same software that somebody else was running, you had to put in a CD or a floppy disk and download it, and it couldn't update itself. You had to put in another disk that you got maybe a year later if you wanted to run the newest version of the program. And you couldn't email. You were limited to the resources and the programs that were on that particular machine. And you couldn't, you could print things out and take them in the real world to other people or mail them places, but there was no direct connection between your machine and somebody else's machine until the internet.
Elements that interact.
Yeah.
Is a network. And then these elements that interact fit into architectures. And then architectures themselves fit into networks.
Or when you say the phrase network architecture, are you saying like the architecture of a network?
Mm-hmm.
Okay.
But they're like, it's like Schrodinger's cat though. Like they're never, you can look at them one time, but they've changed by the time you revisit them. Both the what is the network, how is it architected,
Mm-hmm.
and then when you add multiple layers of it, and then you've got like a complex system.
Sort of. I mean, I guess I think of like the network as more static than that. Yeah, the routing might change, but that doesn't fundamentally change the nature of the architecture necessarily. It might. It depends on, are you just hopping differently, or is something, are you just going to a different router, or are you, changing entirely the I don't know where I'm going.
You brought it back to telecom.
Sorry. But yes, but I do think of architectures as something deliberate and more permanent than just the given pathway at a time. It has more to do with the type of pathway, I think.
I think that's a good point, but I mean, but permanence, I guess, is strange, because I mean that's not how I think of it. I would say I think of it exact opposite.
Well, I mean, there's sort of the logical architecture, and then there's the physical architecture.
Yes.
So, to me, the physical architecture, I mean, there's a relationship, obviously, because if you don't have the plumbing, no connections are going anywhere. But we're not as tied to the physical architecture as we used to be. And so your architecture, you still need the infrastructure, but you have more flexibility in, how you route things, and the resource. You don't necessarily have to go to the same old places that you used to in order to get the resources that you need to do the work you want to do.
Right. But the logic informs the physicality, and then they maybe like they co-evolve, right?
That's a good question. Which comes first, the logic or the physical? Because you don't have the logic until you have the physical, but then the physical becomes the more important part. So I don't know.
And then we have kind of nascent terms like intent-based networking, which I think speaks to the logical dynamacy and the physical shifts that are happening in the network, where the node that used to just do one thing can now do whatever you want it to be as the intent changes. So it's the edge compute node, but all of a sudden we need some core functionality there. And since it's all just a bunch of servers that are connected to power and fiber, there you go. It is what you need it to be. But I don't think we're there yet though, right? That's like kind of aspirational future state of, that's like, you know, flexibility. Like that's flexibility is you make the box what you need it to be when you need it to be it.
Yeah.
The esoteric nature of what is a network, what is an architecture. So maybe we should talk about what is a telecom network architecture.
Kelly.
Look, I have paper and pens.
Yeah.
I'm like,
Are you gonna draw?
I might. Oh wait, what does Sean have? What does Sean have? It says,
Yeah, Sean, talk so you come.
yeah, so you pop up the video because I can't do that.
The theory of complex systems is so you've got telecom diagrams. I've got.
Oh, you. What is that? An economics book?
Not even. Put it on gallery view so you don't have to wait for me to talk for it to change.
Well, yeah, but when you're still small, I can't see it.
Yeah, but he's less small.
Oh, that's true. Okay, all right, so that's better.
All right, so in a discussion of a telecom network architecture, where do we want to start, Kelly? Core?
Sure, that sounds good.
Is that the right place to start?
I think so. I mean, you could start from the edge and work your way in, but the edge is different than it used to be. So maybe we should just start with the core and sort of the way things used to be, because
Yeah, that would be helpful.
I think the core is probably, for all the changes that have happened in the core, that sort of the function of it is still, the idea of it is still the same. And I think
because I feel like I do a lot of writing about the changes to the network. So knowing what came first would be very helpful to me, I think, to give me much, like, you know, a better sense of what those changes really mean.
So like circuit to circuit, packet to packet only. I think maybe packet only is, I mean, I don't know if we need to go back to 2G really, right? And like circuit switch network.
oh, circuit
Probably
switch. Oh
not.
my God, you want to go all the way back to?
No, I don't.
Hold on, I need a
I was thinking more like we could start with like purpose-built boxes,
Okay.
which technically goes back to 2G, but is sort of a little bit less specific.
no one's ever talking to me about circuit switching.
Start with purpose-built boxes. Let's start there.
So networks used to be basically exclusively, big switches, and they were sort of these, I don't know, I have a vague, sort of box-like image in my head, and they sort of needed to be, they were very manual. I mean, it used to be like, oh man, like way back, like it used to, I mean, like you think circuit switch, like literally the women who used to like take the switches and connect, eventually they did, figure out a way to basically put that in functionality inside a box. And so, and they were, and I guess, that was sort of your network. You had a bunch of switches, you had wires that went between the switches, and they only carried voice traffic really, and that was, in order for to add traffic to that, to add customers, you ran a wire to somebody's house, and depending on the type of line, way back in the day, there were the party line where, everybody was connected on the same wire. And if your neighbor was using the phone, you couldn't because it was taken. So you had to wait until they were done. And then, so yeah, it was
I have this sort of concept of, all the way pretty much up until we get to virtualization is that the boxes changed and the complicatedness of the complexity of the boxes changed and sort of the functions of the boxes changed, but they just basically kept adding boxes. And, it was, whether it was, boxes for voice, boxes for data, support for security and call, ring, just all kinds of stuff, like all the functions that all the functions of a network we're basically sitting in a box somewhere in the network, and they would replicate them as needed in order to scale. And so, you had boxes and they were very specific, and, each one had a specific job, and there wasn't a lot of, merging of functions for a long, long time. That's, my sort of sense of the timeline.
So maybe worth like, what is the user plane? What is the control plane?
Okay, so that gets into standards. And that really, I feel like that's in the network, and that's sort of that's where you start getting into the IP stack. And so your user plane, in a very general sense, is basically all the stuff that you do, like when you browse, when you play on an app, when you download something, when you upload something, all of that is user plane traffic. And then the control plane is basically all the things that the network has to do in order for your user plane stuff to work.
Sure. Okay. That makes sense.
All right.
And that goes all the way from the from the airwaves, from the radio access network, all the way, like there's, I think of it as a slice, I guess, sort of, because they're related to each other, but you can do different things with them. Like in 4G and 5G, you can send one over 4G and you can send one over 5G. You can split them. So like that's sort of how I think of it. Like to me, that's an actual slice, because you're doing something totally different with it, but they're still enabling each other.
So for 4G, 5G using same core and your characterization of a slice, you mean like a non-standalone network where it's a 5G carrier signal, but the core is an evolved packet core that was designed for 4G, or am I mischaracterizing?
No. I'm just thinking about it more sort of conceptually than that. I'm not putting it in 4G or 5G. I think it's really interesting that you can do totally separate things with the user plane and the control plane, and yet still, I don't know, like to me, that's sort of the purest slices, that it's one thing, they are one thing from end to end, no matter where they go or what they go through in the network. And because ideally that's sort of what people want a network slice to be. It's itself, and it, plays by its own rules, no matter, what technology it's going on.
So that's,
that's not really a slice, but that's
sure, yeah. To lend an acronym, control user plane separation, CUPS, right? That was like release 14, maybe.
I'm not good on the specifics of the releases. I don't, but that was important, and it sort of laid the groundwork for what you can do in non-standalone, really.
Okay. And you mentioned the core boxes, everything has its own little job to do.
Yeah.
So
and eventually, go ahead.
Oh, just so maybe we just the boring, not it's not boring, it's eminently fascinating. I call it boring because I'm not qualified to like talk in any kind of detail about it. But just like just the kind of the key functionality of the core, the ones that I've got like ready to go in my mind are home subscriber service. That's just a database. That supports other functions, and it's just filled with subscriber information, right? Then gateways, serving gateway, and that's like the interconnect between the core and the radio network, right?
I don't know, to be honest. Like like you start getting into gateways and the specific functions of what each thing in an architecture does, and that gets a little over my head unless it's really obvious. Like there's like adding IMS, the Internet Media Subsystem, to the core was a really big thing. I think that was with the Lte transition. And I wrote about it a lot at the time, but I don't remember a lot of specifically what it enabled. But it was the oh god, yeah, I'm totally blanking. But I think it was, it made, no, I can't even. I have a concept in my head, but I can't verbalize it.
Serving gateway, and then there's the packet data net PDN gateway, packet data network gateway, and that packets, it routes packets. And then the other one that I can pull is MME, Mobility Management Entity, and that's control plane function where signaling and security lives. So that's like the box or the software that knows where your phone is, and when you try to call someone else, it knows where that information is coming from, and then it interconnects with those PDN and the serving gateway to connect you to where you want the data to go.
Yeah, the core is basically I think what I think has been an interesting, so basically, like, traditionally everything has sort of had to go back to the core, in order for your phone to function, it has to, in a matter of milliseconds, send stuff to the core, get stuff back, send some more stuff, get some more stuff back, in order to, authenticate your device, get you onto the network that you're allowed to be on a plan that you are allowed to be on, and if you're prepaid, start charging you accordingly, and make sure that all of that information, eventually gets to the OSSBS systems that's going to send you a bill, and that. But there was a lot of reaching back to the brains, because the brains were only in like certain areas, and I don't know how many. It's easy to sort of think of it as a core. It's like there's one, but I don't think that's how it's ever really been, because there are different regions. You connect into networks. Telecom networks are basically designed as regional networks. A lot of them used to be regional networks. They didn't start out as national carriers. They, started out as little companies that bought up a whole bunch of others, and now we have three major ones. Mm-hmm. And so I think that's important to remember, because there's a lot of infrastructure that's been there for a very long time that, when you think about the relationship of wireline and wired networks, or wireline and wireless networks, some of that stuff is just its legacy, and it's, they're built the way they're built because that's the way they were built, like way back.
That's what it was when we bought it.
Yeah, exactly.
Yeah, so I think that gets into a really interesting area, is like, where is the core and why is it there? And then I think that gets us back to like logic informing physicality, informing logic. And I think like for all of this, the logic is financial logic. So if you were building that network, I've got to cover this many people that are in this area. So what is the most financially expedient way for me to do that? Can I do it with one core site? Because if I can, I will. Because, R's greater than I, and I can make more money and spend less money. But do I need two? Do I have to have two? If that's the case, we got to put another one out there. Hopefully R is still greater than I. Rinse and repeat. So, I mean, yeah, like, where is the core and why is it there? I mean, it's probably there because that was a cheap piece of real estate that also had access to fiber and power and, redundant energy generation and cooling and so on. So, I mean,
well, yeah, but I think the regional nature of the networks ultimately means that you have duplicative systems, and to some extent you want that, because even if it would be cheaper to run a single core to fuel your entire national network, your people on the far ends are going to have a crappy experience because of latency, just physical, like physics. You can't.
That's right. And that's why this is so key to 5G and edge computing, right? Because like you can't beat physics. You can't beat the speed of light yet.
And the other thing is redundancy, because if there's a fiber cut in Missouri and California goes out, like, or you're in you want redundancy so that all of your customers aren't mad at you at once. So it would be great. I'm sure that, you could troubleshoot a lot easier if you only had one physical core location, and you had like 10 guys who could just check servers all day long or whatever. And, nothing, maybe you'd have less outages, but when you had an outage, it would be a huge one. So there's sort of history at work there, but then there's also, some practical positives to having, regional data center hubs. Now I'm close to one of the big ones globally, because eventually all those boxes became servers, and there weren't very many. There are fewer and fewer purpose-built boxes, but it was really interesting to watch that transition, because the purpose-built boxes, they were really, really good at what they did. And they were used to, supporting millions of subscribers or hundreds of, tens of millions of people, hundreds of millions of devices. But you couldn't, it was a pain to take them offline and reconfigure them or update them, or, all those things that you sort of used to have to do to like your PCs. All that technology was sort of did get carried into the telecom infrastructure at the time. And eventually, it was, we want to be able to do a software update to this, but you still, you couldn't, like, sometimes you just had down periods, and they'd try to do them in the middle of the night. And I think to some extent they still do this. If you need to take the network down to do a software update, to reconfigure, to do all these other things, you try to do it at a time of day when almost none of your subscribers are on there, because, you don't want to impact their customer experience. It's getting harder and harder to do that because people are on all the time. But, like, just kind of knowing that your network was going to go down at a certain time, that used to kind of be a thing, like,
Okay, so where do we go from the core? I mean, transport network.
Transport network, like, I don't know, like, I mean, there was a whole thing for a while on sort of the central office re-architected as a data center.
Cool.
I don't think Cord, yes. I think, was it, I want to say Telefonica did kind of a, like made it a thing maybe. And I think maybe AT&T explored it a little bit, but I don't know whatever happened to that. So the telecom companies had central offices, and I'm not as familiar with sort of the infrastructure of the phone companies, because I think that's sort of what it dates back to, is they had these I think they were connection points, or they were
switching. It was
switching, I guess. Yeah, it was, so they had these legacy locations basically. And for a while there, when they realized that they were going to have to spread out compute and become more distributed, like you couldn't just have, you know, 2 core locations, you know, one in the east and one in the west, and that wasn't enough anymore. You know, you needed more real estate, you needed more servers, you wanted lower latency, you wanted to, you know, run more stuff, and you wanted to do it closer to your customer so that they had a better experience. And so there was a movement for a little while, at least, to basically make these central offices into data centers. And so that was like a movement toward edge computing. Like that would be your new edge, you know, and everywhere you had a central office, then you could theoretically have a ton of stuff to run your compute on. But it turns out that I think they ran into a lot of problems with the buildings because they weren't really set up to, I mean, servers need a massive amount of cooling. So I live like 15 minutes from Ashburn, and there are just these gigantic, like 2 or 3 story cement bunkers, and like they will have, you know, fans as you know, 6 or 8 foot like vents that just line the sides of the buildings because there's so much heat that comes out of these things. And you know, so you keep it, you know, and you need a massive amount of power, you need a massive amount of fiber connections. And it turns out their central offices, you know, I think maybe by the time that sort of came along, the internet was so well developed that you couldn't all of a sudden just get those things. And there were already data centers that were cropping up in new places that were a lot cheaper and easier to, you know, to make those connection points at. And so I don't know to what extent Cord kind of is still going on.
I feel like, I mean, that the acronym is certainly not used with any kind of regularity, but I think that the concept is eminently applicable to edge compute. Like we've got physical space that is connected to power and fiber.
Yeah.
What can we do with it? What's the highest and best use of that? And, you know, particularly with virtualization and move away from purpose-built single purpose box, you know, what can we do with what we've got here? And that's where you get into like, okay, well, we've got this many racks, this much power. This is what we have to do. This is what we'd like to do. So is there room in there to put an edge compute server? And we can see if there's a service that we can deliver in this area. And
I'm going to get out my thing now, and I'm going to draw. So like, and so you've got, okay, so you got your core. So you got your core network, and then like down here you have your little cell towers, and they're all 3-sector cell towers because they're nice and neat that way. I don't draw very well. So yeah, so you got a bunch of towers. So then these towers, well, I suppose I probably could have done CRAN, but let's keep it simple. So we've got towers way out here on the edge of the network, and they have to get their stuff back to the core. So, you know, so they have, it used to be T1 lines, like and replacing those was a huge thing. So basically they have some kind of, it used to be old like data connections to, and say you're in a city and, so you're connecting these guys out at the very edge, and then you're connecting, into some kind of aggregation point. And, and then your aggregation point, it hops around the internet, hop. And, however many, less hops is better. And eventually you get to the core network. And so you've got traffic sort of going back and forth. So and at some point in here you hit, maybe after, maybe it's just 1 or 2 hops, you kind of get to an internet backbone. So it's, super high capacity, takes you across the country, these, huge, pipes of fiber. I mean, I don't think physically that's what it looks like necessarily. Although some of them I think can be pretty thick, but, and, so internet backbone, to whatever core location, because, they're regionalized, but I still don't think there's a ton of them, I think it did really used to be, there was East and there was West in the US at least. And and that was it. You went to the closest one and, and that was it. It's a little bit more complicated now, but that, that was, so like, this is what I think of as like, this is an architecture.
Eiffel Tower, got it.
Oh my God. Well,
yeah, that makes sense to me.
So, but then things got complicated. So, you used to have, just your macro towers. Sorry, Sean, is it okay? Am I going?
No, so now they get complicated.
Well, maybe it's just complicated for my drawing capabilities. Okay, so you used to have a tower, and so okay, all right, you know what? No, I'm gonna make it a monopole. Okay, so you have your tower, and you've got your antennas, and it goes up and up, and you see these along the side of the road, and
pretty good, yeah.
Yeah, right. The thing is just boxes. And so each of these has, an antenna inside it, and it's got a bunch of ports down at the bottom, and we got to plug into stuff. And then you've got like a shelter down here at the bottom, and, that's sort of where your like there's a bunch of electronic stuff that runs there. Generators. But I mean, there's also like, this is where the baseband used to live, right?
Oh yeah.
So, all right, so where am I going with this? So you'd have stuff running down the tower, and and they would.
Is she going to talk about CIPRI?
Oh, don't make me talk about that. I don't want to talk about CIPRI yet. Like, I feel like that's like, can we just talk? So I was actually just going to do like, since we've done, okay, so this is probably key. So like when people talk about backhaul, generally they mean sort of this hop. They mean this stretch of the network from the tower to sort of an aggregation point. Okay. And it can get a little fuzzy, how many aggregation points, do you go further, do they bring in the stuff from over here too, but this is the general concept. So you backhaul all your traffic from the tower, and eventually you get into the transport network, which is sort of the more, it's the bigger branches, you get to it's not necessarily the stuff that goes directly to the tower, it's stuff that you connect into to connect the tower to everything else. So, and when people say internet backbone, they mean sort of the biggest branches of the connections that run across the country and the world. And some of those are subsea cables, but there's a lot, like there's physical trenches had to be dug. Okay. And all that stuff is super expensive, probably not going to move, it's just there's legacy infrastructure there that, you know, is just, this is the network that we have. Doesn't mean it will be the network that we always have, but it's, the highway is there.
And hold that up again, please. So you've almost drawn out a star topology of a transport network.
I'll tell you what, I will draw you a star. Okay.
And if you put a ring around the star,
Then
that's pretty much what transport networks in metro areas look like.
yeah, so they talk about metro rings because, you know, when you go out from, you know, whatever you're, you know, usually like yeah, so that's how internet, you know, networks were built, just by like, you know, they put in a bunch of fiber to a bunch of places, and, or not, well, it wasn't fiber at the time, but, you know, they were connecting mostly, you know, government, businesses. They were connecting, I mean, I guess a lot of it ran on the old telephone infrastructure at first, or it followed the same, you know, it follows the right of ways, because that's where you can, that's the easiest place, you know, that's where you dig.
Mhm.
And yeah, so yeah, so so all of the front haul stuff in a metropolitan area tends to kind of branch out like that.
And rings because financial expediency.
Yeah, I mean, and because I mean, I think it's probably easier for, you know, redundancy too. I mean, you know, yeah, you can get a cut somewhere in the ring, but depending on where it is, you know, you might be able to work around it too. I don't know, depends. So wait, so where was,
Back to the monopole drawing.
yeah.
From
Trying to figure out if I did another drawing for front haul though. So like your sites used to basically look like this, you know, and yeah. So, well, then they sort of decided, well, so if we're connecting all of this stuff by fiber anyway, like, is there really any reason to limit where the radios can go? Does it have to go on a tower? So all of a sudden it became, well, you know, okay, here's, you know, a city, it's a really fancy city, and, you know, here's my street poles, and I'm gonna smack one here on all these little poles.
Right.
But I'm just gonna, this is just gonna be a radio. And then I'm gonna run fiber to each one of these, and power, because you have to have power. And I'm gonna run all of these into like the basement of this office building where I have what they call a base station hotel. And so you'd basically just, so instead of the stuff that was in this shelter.
Yeah, the box thing.
Yeah, so instead of all that stuff like living at the bottom of each one of these streetlights,
Sure.
they'd put it all in a basement somewhere, and then they would just stick the radios up wherever they wanted and run fiber to them. It's still expensive, but you don't have as much infrastructure at every single site, and it's a way to be a little bit more flexible in where you put your stuff.
Yeah, okay.
So you've centralized your basebands.
Now you've centralized the baseband.
Used front haul to connect your radios, which lets you densify your network, offer up a better, more consistent service at street level where people are, and particularly important in the context of millimeter wave. But you've also gained an operational efficiency, because now instead of one baseband at the bottom of a tower feeding the radios on that tower, you can coordinate between multiple radios from one baseband site. So you can take in data about how the radio capacity is being used, and you can tune it. You can make adjustments. So you can make higher and better use of your limited resources in X area through centralized coordination.
So I feel like this is a good place to mention sort of the HetNet concept. Even though it's sort of gone away. I mean, it's still there, but people just don't, it's not so much of a buzzword anymore. So like there was the, so densification has, so this idea, so there's only so many, your radios can only handle so many users. But for every other radio that you put into place, that those radios can handle users on the same spectrum as long as you don't have interference between the two sites. And you plan your network so that your sites don't, there's, so that intercell interference is, hopefully not a huge issue, that you get smooth handovers instead of things like dropping between when you go from one cell to the next. So, so you can reuse your spectrum.
Yeah.
So the heterogeneous networks concept is, okay, well, we want to increase the use of our spectrum by, instead of just having everybody on this macro site, that everybody who's on this half of the city being on this macro site, we want to build small cells. And those are going to be smaller. They're going to be closer to the user. They can't handle as many people and devices as the big towers, but they are, maybe they're in urban canyons where the macro tower coverage isn't very good. And you can plan sort of a layer of these things that, people will use them. They walk in and out of the coverage. They walk from cell to cell. And so there's more handovers because you're closer and, they're spaced closer together. But you can essentially, you can really increase the capacity of your network by adding all these radios that reuse the spectrum. And you have to plan so that you don't interfere, so that maybe you change the tilt on your antennas of the macro so that they, so that they don't necessarily interfere with this, or it's all based on signal strength. And so, if your phone is getting a better signal from this one, it's going to kind of ignore this one.
Okay.
So yeah, so that was a big thing. The
6 years ago, maybe.
God, was it really that long ago? Yeah, there was like, what was the HetNet forum is now, was it WIA that changed its name for a while?
It was HetNet forum was part of WIA.
Well, that's right. They had a specific WIA, like this was a real thing for a while. And I mean, the concept is still there. And obviously everybody wants to densify, and that hasn't gone away. That's intensified, if anything. But that's sort of where it started, was this idea of, you have heterogeneous networks.
Interesting. Yeah, I haven't heard that term at all, despite writing a whole report on network densification and small cells. But
it's kind of old school at this point.
Yeah. Terms come and go.
Yeah, I'm just like surprised no one threw it out there, because I'm new, but I was talking to people who aren't, so I was surprised. Okay, cool. That was wildly helpful.
Oh God, we've been talking for 53 minutes.
We didn't talk about full duplex, half duplex. We didn't talk about microwave backhaul. So much more to cover.
Oh, integrated. We could talk about integrated access backhaul too.
IAB's release 17.
Access backhaul. I've heard.
Am I getting ahead of the standard?
You're right there with it. I think our friend Prakash wrote a good piece in Forbes about IABs and why they're important for rapid millimeter wave network deployment, because it saves you the time of trenching fiber and pulling the permit by reusing your spectrum to backhaul your traffic from your small cell to a different small cell that might be connected to fiber.
Integrated access backhaul I know about. Okay. Amazingly. I think I ended up covering that to some extent in the network densification report. So, I mean, still definitely something we could talk about, but I am familiar.
What do you want to talk about on the next one of these?
Can't we just have part two of
two? Yeah, I mean, what, like more RAN focus maybe?
Yeah, that could be.
We could talk about like
mean, if we're going to get into like full duplex and half duplex, which I feel like I have to do some Googling because and there's OFDM, the waveform, and like stuff like MIMO and, a lot of sort of the complicated air interface stuff. I think it's probably worth throwing in some of the, did the X2 interface? Oh, the other thing I think of is would be worth mentioning is the difference between sort of the mechanisms of oh God, what's the acronym? It's the broadcast, LTE broadcast, because people keep trying to make that a thing. And I don't know if it's ever going to be a thing. And they're like redoing it for 5G, right? So that you can.
Yeah. It never took off with LTE.
No, it's EMBMS. That's what it is.
Mm-hmm.
I'm enhanced
I pin too.
multi. Yeah. I don't remember. Some broadcast is in there somewhere. But because I think this is sort of an interesting thing overall, because you have sort of the advanced standards.
Multimedia broadcast multicast service.
Yes. Yeah, that's a whole thing. Because I think there's some interesting things happening on sort of the advanced standards and broadcast are trying to become two-way, and like people keep trying to make broadcast happen in cellular, which is fundamentally two-way, and it's I don't know, that's sort of more of a philosophical question at this point.
All right, so next time we need to talk about the RAN a little bit more. We need to talk about active antennas, passive antennas, full duplex, half duplex, varying degrees of MIMO, phased array antennas. We'll save heat sinks and integrated circuits for another one.
Yeah.
Orthogonal frequency division multiplexing, dense wave division multiplexing. We can get into that.
Ooh, we could get into time division versus frequency division.
TDD, FDD, and aggregating between the two for all the T-Mobile users out there now that
and the what?
Aggregating between FDD and TDD with your Snapdragon 888, where now your 600 megahertz and your 2.5 can be aggregated together.
See, I don't like that. Just seems so complex to me that I like mentally I have like you can do frequency and time division at the same. Like that's like it's the difference between space and time. Like that's a huge difference.
Well, this was fun.
It was actually very, very helpful. So
I'll be prepared to draw next time too.
You'll probably find that we're like, I'm sure some of it's wrong.
Yeah, approximately 30% of this was probably accurate. No, I think it's more than that. Definitely more than that.
Hopefully.
Yeah, I mean, I still think and actually your drawings were very helpful. I know like you feel like they were silly, but visualizing some of it, and some of this is completely new to me, but a lot of it is not completely new to me. So really this is just helping me really connect dots I was struggling to connect while talking to other people during interviews and my own research and writing. So I don't need it to be like 100% accurate or clear all the time or anything. The more I hear about this stuff, the easier it becomes to really like internalize it. So
journalism, it's all about broad strokes, and pretending to be an expert.
Yeah.
And learning every day.
And learning every day.
Learning every day.
With your colleagues over coffee, over Zoom.
Yes.
Yeah. All right. Well, This was great.
Yeah.
All right.
I'll post it on the internet.
Okay.